Okay, in this tutorial I would like to look at proportional symbols as a mapping technique used to present data. Now, it's quite a simple technique. It's probably one of the easiest of the main mapping techniques that you are used to present data, and therefore it's very popular with map makers. One of its main strengths as a mapping technique is it's very easy to interpret. First thing you need to look at is the key. Here, for example, and have a look at what each symbol size actually represents. So for example, this symbol here in California clearly matches the large symbol here, so we know that the population, or the Hispanic population of California, represents 10 million. We can also see up here in Montana that we've got a very small symbol, so the Hispanic population must be less than 10,000. So that's its first main strength, is that it's easy to match symbols with the values from the key. It also then allows you to very clearly see patterns and compare. So for example, I can see that this state here, which is California, has a much higher Hispanic population than its neighboring state of Nevada. I can, however, see that overall, if I just remove all of this, that California, over on the sort of southwestern part of the United States, has generally quite a large number of states with higher Hispanic populations. In contrast, I can see that this northern region of the US has very low levels of Hispanic population. I can see there's a cluster in the northeast of the country of states with relatively high Hispanic populations. What you can see here, though, is the first big problem. And that is the exact value of a symbol can be slightly difficult to work out. So whilst it's very easy to be able to match up this symbol with the largest, we can see here that in this state of Arizona, the symbol is clearly bigger than the second symbol there, but is nowhere near as large as the largest. So we know that Arizona must have somewhere between 100,000 and 10 million, which is a huge jump. And that's one of the problems here, is the actual key is not maybe as good as it could have been. There could have been a more sophisticated key that showed the scale more appropriately. Right, if we have a little look at something else you can do with proportional simple maps. In the second example, you can see that the symbol represents the total population. So if, for example, you have a big symbol like you have here in California, it means that you've got a very high total population. And that's roughly, 3 times the size of this one here. So we would say it must have roughly 30 million. What they've done, or the map maker's done, is they then subdivided each of the circles into the proportion of the population that is Hispanic. So the red represents the proportion, and I can see that in California both has the largest population and that roughly 1/3 of it is Hispanic. I can see, for example, in these northern states, they almost have no Hispanic population relative to their total population. I could see that up here in New York State, that they've got roughly 1/6 of the population is Hispanic. So it's almost like using little mini pie charts, but making the pie bigger, or the circle bigger or smaller, depending on the total. In this third technique, the map maker has used the actual symbol to represent what it is they're trying to present. So here we're looking at wine consumption, who's drinking the most. And we can see that there's a really large bottle here, which shows us clearly that the French are drinking the most. Now we have no key, which is a problem because we don't know what these values mean. So the map maker's actually simplified that by putting the amounts here onto the map. But if you're going to use this technique to present data, then you would expect to put a key. Another big problem I have with this particular map, though, whilst it's a very visual and really, allows the largest symbol to jump out, which is one of the main advantages of this type of technique, is that we would expect France and Germany to have the largest two, because they have the largest two populations of the countries shown on the map. So, whereas Luxembourg has a very small symbol here, and we'd expect that because it has a very small population. So what would probably be more effective is if the person had worked out the per person wine consumption rather than the total. Right. Have a little look here. We can see a really quite effective key now. And we can see 5, 50, 200, 500. And we can see Oslo very clearly has the largest population down here. We can see that there's a real coastal pattern of cities with large populations shown over here on the west coast. We can see that there's a very few with small populations in the further north. And where this type of mapping technique comes really useful is if you then had a series of other maps of Norway that indicated other features. For example, that the climate up here is very cold, that the central region of Norway is very mountainous, which explains why there's no urban areas, that this is a sheltered area with huge trade links to Europe. So if we had another series of maps, we could then start to understand this pattern more, which is why you would want to present your data to show this. Okay, just to finish off with, I want to have a little look at a couple of examples of how this mapping technique has been used. So if we talk about the COVID-19 outbreak, we can see that the map maker here is mapping the number of cases across China when it first started. And we can see Wuhan very clearly jumps out because it has a large symbol. Now we would need a key to go with this, so we could understand how many cases that represented. But your eye is drawn very quickly to that area. We can also see that the East Coast has a high number of cases, and that as we move west, there's very low levels of cases. We could also compare China with its neighbours, where we can see relatively low levels of outbreaks happening across Asia at this particular stage, well, this stage being day 29 of the outbreak. So the technique's been used really effectively to show a pattern and distribution of outbreaks. And each circle is on the location it's occurred. Problem, and the major problem with this technique, comes from when some get much bigger than others. So we can see Italy here has a huge outbreak compared to other areas of Europe, and it's so large the circles had to become really large. What it's then done is it started to overlap with other circles, so we can no longer see some of the smaller outbreaks across Europe because they're overwhelmed by Italy and to a lesser extent Spain and Germany. Another problem here that we can start to see is that I don't actually know if this is Italy. Now I know this is Italy because of the pattern of the disease, but to actually work out where a circle represents is you have to find the center of that, and I can see that overlaps with Italy. But you can see how that might be quite difficult, especially for some of these smaller circles. Which country are they actually sitting on top of? And it looks just a bit of a mess of circles. But one advantage, I suppose, of doing this is I can at least compare the whole of Europe and see that there's been a really bad outbreak in Europe compared to maybe Africa, for example, which lies to the south. Right, so there's me discussing the technique in general. I've talked about some strengths and weaknesses of the technique and how it can be applied. You should use your textbook also to pick up some more points in answering any question on proportional symbols.